See this? They are asking that if the eigenvalues of A are lambda 1, lambda 2, lambda 3, so on lambda n, then they are asking us to prove that eigenvalues of A square are lambda 1 square, lambda 2 square, lambda n square. So it is nothing but, if you have a matrix like this A, B, C, D, and you found out that the eigenvalues of this matrix are 1 and 2, or let's say 2 and 3, okay? These are the eigenvalues. Now they are asking us to prove that if this is the case, then if you find out the A square, which means if you square the matrix, then the eigenvalues are also going to be squared. Got it? So what does it mean? If you take a matrix and if you take the power of it, then the eigenvalues are also going to be, so and so power. So just see how it works. Now, first of all, so it is not just for the square, you can even go for n also, a power n. If you put a power n, then it is going to be lambda power n, lambda power, lambda 2 power n, lambda so on, lambda n power n. In the sense, even if you increase a to the some random power also, it works. A power m, then all the eigenvalues are going to be raised to the power m. I hope you are getting it. What I am trying to say is, if you find out the eigenvalues of a matrix, and then if you find out the eigenvalues of the same matrix raised to the power m, you will see that the eigenvalues are also raised to the power m. That is what I am trying to say. Okay, let's see the proof here. Now they have already given that. So lambda 1, lambda 2, so on lambda n are the eigenvalues of A. So just I'll substitute, I'll assume that in order to deal with all, without dealing with lambda 1, lambda 2, so on lambda n, I'll deal with lambda itself. Okay, so let lambda be a characteristic root of the matrix A. Fine, let lambda be a characteristic root of A, which means in place of lambda 1, lambda 2, so on lambda n, I'm just substituting lambda. Fine, then we know this equation, A into x equal to lambda into x. This thing you know it, right? If A is a matrix and if lambda is a eigenvalue, and let us assume that x is the characteristic vector, that eigenvector, then we can write this Ax equal to lambda x. This is nothing new, we already know this. Now I'll just take this equation and tweak it a bit. So I'll try to multiply with A on both these sides, which means on the left hand side I'll multiply with A, on the right hand side also I'll multiply with A. And when I'm multiplying with A from left side, the value of the equation should not change. Therefore, I can do that. Fine. And now see this, A into A is nothing but A square. So this got reduced to A square into x, and then lambda will come out. I'm just pulling out lambda and I'm sending A inside, which means I'm multiplying A and x. We already know that A into x is equal to lambda into x. Therefore, in place of Ax, I'm substituting lambda x. Then what does it become? A square into x will become lambda, will be equal to lambda square into x. Now if you observe this, it is exactly in the same form, Ax equal to lambda x form. What does that mean? It means that this is the matrix and this is the eigenvalue and these are the eigenvectors. X is the eigenvector. Therefore, from this equation it is clear that if lambda is the eigenvalue of A, then lambda square is the eigenvalue of A square. Therefore, if lambda 1, lambda 2, so on lambda n are the eigenvalues of A, then lambda 1 square, lambda 2 square, so on lambda n square will be the eigenvalues of A square. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. after taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.